Hello and welcome friends in this particular module which is dealing with precision in leveling. We'll be coming across many terms that have been discussed in module 2b as well as module 1.4, module 3b1. So my sincere request to you all to go through the contents of these particular modules before entering into this content. I'm going to cover some specific content here which is dealing with precision, sources of errors, permissible error in leveling, degree of precision, mistakes in leveling, general precautions to reduce errors and mistakes. As you learn this content, I wish you to be able for classifying the sources of the errors in leveling work in land surveying, work out permissible error and assess degree of precision in leveling work, and to take general precaution to minimize errors and mistakes that could be involved in leveling works. To start with, already you know what is precision and accuracy as far as surveying terminology is concerned. So whenever we wish to have any surveying measurement, we want it to be precise yet accurate. By precision, we mean the measurements are close to each other, whereas accuracy wise, we wish to see that all that particular measurements are close to its most probable value. So we wish to enhance the precision and also the work accuracy wise as far as leveling work is concerned. This can be done by repeating the measurement. That is, as you repeat the measurement, you can have some errors nullified, and accordingly the average of that will be very close to the true value. Hence, the precision can be enhanced. Similarly, in leveling work, you are expected to start the work from point of known elevation, which is nothing but the benchmark, as well as you are expected to close your work on certain benchmark. On a stretch, on that particular run, there could have been lot many benchmarks. So here, as you have the readings on these particular intermediate benchmarks, it will apply the frequent checks on the process that you are going through. You also know that you are provided with lot many kind of levels. It could be dumpy level, tilting level, it could be precise level, it could be auto level, it could be digital level. So depending on kind of the equipment, the level that you use. You also know that ordinary staff are provided with 5mm strips in order to take the readings, whereas there are some staff which could also be giving you some opportunity to read in millimeters also. So the kind of the equipment that you involve, it will also help you to enhance the precision in leveling. Keeping that particular equipment in good adjustments as well as applying the good skills to take the measurements is also helpful to enhance the precision in leveling works. As we carry out the leveling works, it is quite probable that we may come across instrumental errors, natural errors as well as personal errors. Already you know all the constructional aspects of the various label as well as the stuff. So if anything goes wrong with any of the part, maybe leveling head, maybe spindle, maybe tri-brass trivet, maybe telescope, maybe longitudinal level tube, maybe eyepiece, etc. So this deviation will cause instrumental errors. Broadly, we can think about the line of sight, axis of telescope, and some internal arrangement of that particular telescope. So, if that particular line of sight and line of collimation are not overlapping each other, there should be something wrong with the position of the diaphragm, optical center of the eyepiece, as well as the optical center of the object glass. As well as here, this particular internal focusing lens may not be sliding properly. That means there is involvement of this particular instrumental error. As you know, as we look through the eyepiece, we will get some such view showing vertical hair as well as horizontal hair. So this particular horizontal hair as well as the vertical hair is helping us to take the readings. So this particular horizontal hair, as it serves the purpose of horizontal reference, if found to be tilted, there will be involvement of instrumental error. You also know that the equipment is to be mounted on tripod, which normally consists of telescopic lens. So it will be provided with certain metallic shoes, it will be provided with some kind of the clamps. So if they are not working properly, if the nuts that are provided in order to fix the caps over these particular legs are not working properly, tripod legs will be loose. And because of that, it will hamper the leveling operation. The staff that we use, if do not have the proper graduations, it may not be of correct length. Hence, such points could be taken into account while defining these instrumental errors. There could be involvement of natural errors also. As we have discussed previously, in leveling, we deal with leveled surface, which is the surface parallel to the mean spiral surface of the earth. The way we discussed about the rise and fall method and collimation plane method, you already know that we wish to have these particular level surfaces parallel to each other in order to facilitate the computations the way we did. But we have certain limitation related with the constructional aspect of that particular level. We cannot define that particular level line which is joining the center of the eyepiece as well as center of the object glass. Hence, we have to resort to the horizontal line. So, having this particular horizontal line involved, we take the reading other than that could have been given by this particular level line. Similarly, in the vicinity of the Earth's surface and at the end of the staff where we wish to read, there will be change in the atmospheric density, because of which the ray which is defined as horizontal line will no more be horizontal line but would be refracted one. So these things are not in our hand. These are certain natural limitations, and hence the error could be considered in terms of curvature as well as refraction. Over the day we could be working, so in the morning, in the noon, in the evening, as we consider, there could be lot of temperature variations. Even it is quite probable that as we work in the immediate vicinity of hot asphalted surfaces or desert-like areas, there could be considerable glare, which is called as shimmering effect. It is also probable that the blowing wind won't facilitate exact verticality of the staff that we are holding. Even the legs which are to be firmly fixed on that particular ground may not be exactly firmly fixed. They could be there could be certain settlement in that particular ground surface. Hence, the settlement of the instrument or the settlement of the turning point because of the nature of the ground on which we are working could also be treated as one of the natural errors. Now, the personal errors are occurring unknowingly. We wish to have that particular instrument perfectly leveled, but the perfect leveling beyond our capacity may be one of the reasons that is treated as personal error. Focusing of the eyepiece, focusing of the object glass, and hence the involvement of the parallax would cause the incorrect star reading. It is quite also probable that while taking any star reading, the star position could be changed. The star reading taken could be recorded in erroneous manner. While taking the reading, the star may not be fully extended. So, some such reasons could be treated as personal errors. Let's try to understand about the error likely to be involved due to non-verticality of the staff in leveling operations. We wish to have this particular staff held as AB here, but because of the blowing wind or because of the personal error, staff could be leaning towards the equipment, or it is quite probable that it could be leaning away from the equipment, or even the movement is possible sideways. Because of such movements, there will be involvement of error E. For this particular typical case, we wish to have the staff reading as AB, whereas the reading rate is AC, hence the error involved is AC minus AB. Here, further this AB can be considered to be AC minus cos theta, and hence this error can be AC into bracket 1 minus cos of theta bracket complete. As we use this particular expression, say for a particular case, if the staff reading is 4.5 meter and the tilt involved is of 5 degrees with respect to vertical, error involved would be 0.018 meters, and hence the correct staff reading could be worked out as 4.482 meters. Also, if the staff reading is 2.5 meter, the way we worked out error here, it could be simply 0.01 meters. Hence, it's better to avoid higher readings. One thing we must take into account here, determination of this theta for each of the readings is not feasible operation. Hence, it's better to make use of the pond level that is provided with the staff and to follow particular measures to keep the staff vertical would be better proposition. The error that is occurring in the leveling work can be treated to be permissible if it follows this expression, where E is equal to C root K, E is closing error, C is certain constant, and K is distance travelled by the equipment in kilometers. The concept will be more clear as we move ahead. There are various expressions given by certain agencies. So the way you see, typical leveling works can be brought under these particular heads as rough leveling, ordinary leveling, accurate leveling, precise leveling, etc. So here, for each of these particular classes, we can make use of different expressions. Here, certain category precise leveling, the way you see, it expects 1 millimeter error as permissible error per 1 kilometer distance traversed by the equipment. But even in precise leveling, there could be different classes which would be allowing you to have this expression revised as 4 root k, 8 root k, 12 root k, and accordingly. Even instead of simply expressing that particular permissible error in terms of distance traveled by the equipment, literature tells us that this particular permissible error could also be expressed in terms of the number of level setups. So I am keeping the same terminology as I have referred to. So here, as you see, the expression is given as C is equal to plus or minus 5 root n, where this 5 is nothing but the desirable constant. N is actually number of leveling setup, and the C is nothing but allowable loop closure. So say if we are having certain 9 setup, so the permissible error will be plus or minus 15 mm. Even for certain construction surveys, similar expression can be had as C is equal to 0.6 root n, and the value expressed is in centimeters. What I mean to say is, there could be expression like C root k, there could be expression like, say, some constant root n. These kind of expressions are devised depending on one's experience, the quality of the work that is expected, the terrain that you are working on, atmospheric conditions, and the expertise involved, and similar things. Now, as we close the work on certain benchmark, we'll be able to know about the distance traveled by the equipment, as well as having known the initial value of the benchmark and the value computed at the time of closure, you will be able to determine the error that is actually involved in that particular leveling assignment. So say for example, let's consider case 1, wherein the closing error is found to be 10 centimeter. Just to have this particular more elaboration, as the value of the benchmark is 100, here let's assume this value to be positive, and the computed value is 100.1 instead of 100 meters. Hence, the permissible closing error can be computed for ordinary leveling as 24 root k, which comes to be 7.2 centimeter. The way you see, actual error involved is 10 centimeter, whereas allowable one is 7.2 centimeter. Committed error is more than allowable, hence one is expected to repeat the entire work. Let's consider the case 2 in which the closing error is plus 5 centimeter. So this value being smaller than the permissible error, the error can be distributed in cumulative manner with appropriate sign. Say, this particular run involves two change points. Hence, we wish to apply that particular correction at three places. One at change point, second at second change point, third one will be at benchmark. At each of such stations, the magnitude would be 5 by 3, which comes to be 1.67 centimeter. As the error is positive, correction should be negative. Hence, at CP1, the correction will be minus 1.67. At CP2, correction will be minus 3.33. And at benchmark, the correction will be minus 5. It is needless to say that all the intermediate stations will have the same corrections as that is applied at respective change point. In addition to errors, we can also take into account the mistakes. So it could be related with improper usage of the staff, holding the staff at different places for whole site as well as back sites. There could be wrong readings. As you know, the length of back site or fore site for a category of the leveling work better to be restricted to 50 meters. So here, if the length of the sites are long one, as discussed previously, because of the curvature, because of the reflection, because of the inferiority of the line of sight, the readings won't be correct one. As well as while recording the notes, we may commit some mistakes. Some people are habitual to touch the eyepiece or even the leveling screws, or to keep the hands on the timber tripod. This causes the deviation of the bubble from its center location. So touching the tripod or the instrument during the reading also involves the mistakes in working. Hence, it's better to take some precautions. Always start and finish the leveling run on a benchmark and close the loop. Say, for example, we are starting the work from benchmark 1 here. We have read station A and some similar stations. But as we close the work, as we are done with this particular leveling run, we must close the work on certain known benchmark. It is quite probable that one may have the fly leveling and reach back to BM1 in order to close that particular work. As discussed previously, as we balanced the backside and foresight, the involvement of the error is nullified in the calculations. For the various classes of the works, the length of the site could be 50 meters, 60 meters, 90 meters, but better be it restricted to 50 meters. It is necessary to have this particular change point stable as well as well defined in order to avoid the sinking of the staff as well as sinking of the tripod, hence having erroneous readings. As discussed previously, this particular shimmering effect, which is because of the vibration in the paint light or the reflection of the heat waves, may involve some natural errors. Hence, it's better to avoid the lowermost part of the staff as well as even the upper end of the staff, but keep it restricted to say 1.2 to 1.52 meters so that it will be having more correctness as far as effects of the inclinity or effects of this particular shimmering and refraction is concerned. We can reduce the errors as well as we can eliminate the mistakes by broadly observing these things. As we take the reading, it's better practice to check the position of the bubble before and after each reading. As we discussed previously, you are provided with the reflecting mirror so that while taking the reading itself, you can judge the position of the bubble as far as longitudinal level to be concerned. Even you can consider the pod level position. Keep your eye always on the pond level provided on the staff in order to maintain its verticality. Balance the foresight as well as backside. As we run the line in the forward as well as the backward manner, it enhances the precision as well as the accuracy the way we discussed in earlier slides. Lastly, it's better to apply arithmetical checks as you record all the readings in your page of field book so that you will come to know that whatever the computations that you have done in order to work out the reduced levels are correct one. So I hope all the concepts that we have discussed through this particular presentation are clear to you. You can give me feedback. Thank you for your attention. In the coming presentation, I will speak about the error involved because of curvature and refraction and the correction that can be applied. So, bye till then. I wish you very happy learning. Thank you very much.